Let's break down that day one Calc 1 limit. This is the math guy, Steve. All right, this one here says evaluate the limit of x squared minus 4 over x minus 2. Okay, so our first attempt in trying to find the limit is by plugging that limit in. In other words, plug in 2. But we notice we plug in 2, we get 2 squared minus 4 over 2 minus 2. In other words, 4 minus 4 over 0, so 0 over 0. Now, this is an indeterminate form. If we get some solid number, some full number, some whole number, right, or just some integer, if it evaluates to something, a real number, then we just say, well, that is the limit. But this one doesn't, right? So because of that, then we'll have to try some other tools. Right now, when we get this 0 over 0, this is called an indeterminate form, one of the many indeterminate forms, like 0 to the 0, or 0 to the infinity, or infinity over infinity, or infinity over 0. There's a bunch of different kinds, right? Infinity to the infinite power. And so when we get this form, 0 over 0, then we know where there's other tools we can use. The first one we'll try here is factoring. Factoring is always helpful, right? So if we rewrite this x squared minus 4, it's the difference of squares. So we rewrite this limit as, this is the limit as x approaches 2 of x minus 2 times x plus 2 over x minus 2. But we note that the x minus 2's would then cancel. So really this is the same as the limit as x approaches 2 of just x plus 2. Now we try plugging in that 2, and notice we get, this is 2 plus 2, so 4. Okay, so that is an evaluation of our limits. That's one method, right, by factoring. Whereas another method we have is using what's called L'Hopital's rule, okay? This is a famous mathematician from a long, long time ago, okay? And L'Hopital's rule said if I do get a fraction version of one of those indeterminate forms, 0 over 0, infinity over infinity, if we do get that, and then we're allowed to just take the derivative of the numerator and denominator, top and bottom, right? So if I rewrite this limit as x approaches 2 of x squared minus 4 over x minus 2, I'm just rewriting it. Then we say, well, once I get the evaluation of 0 over 0, once I get that form, then we say, we put an equal sign. Typically, we put the equal sign. If we're using L'Hopital's rule, we'll say, well, what I'm going to do now is by putting an L apostrophe H is saying, I'm going to use L'Hopital's rule, okay? And so, meaning I'm taking the derivative of the numerator and denominator. So this becomes the limit as x approaches 2. And then if I take the derivative of this numerator, derivative of x squared is just 2x, derivative of negative 4 is 0, and derivative of x is 1, derivative of negative 2 is 0. And so this simplifies to the limit as x approaches 2 of 2x. And now we plug in that 2, okay? And so we get 2 times 2, which is 4. So we get the same limit, the evaluation of this limit, but using two different methods, okay? Make sure you subscribe to the YouTube channel so you don't miss any of the solutions. Always remember, math is everywhere. All right, Calc 2 people, let's finish that day one review. It's the math guy, Steve. All right, so here we're evaluating this integral of x e to the x squared dx. Okay, so how we do this one is by noting, well, anytime we can, look out for a u-sub. More specifically, we're looking for the du in the problem, right, or in the integrand, right? Is du sitting there somehow? If we consider what the u would be, is du somewhere in that problem? And so here, if we try to let u equal, say, x squared, right? Then notice what du is. So du would be the derivative of x squared, which is just 2x dx. Well, notice that x dx is in this problem, right? And so the 2, we can manufacture that by just saying, well, let's divide both sides by 2. Okay, so half du is x dx. And so now we have exactly the rest of the part of the integrand, right? So we have the x dx is still sitting there, and then this would be our u. And so, again, we're kind of thinking ahead when we're considering u-subs, right? Is the du somewhere in the problem, or can we manufacture it? And so here's our sub-bubble. I call it a subble. Okay, here's our sub-bubble, our subble. And now we rewrite this integral as the integral of, well, we just said the x dx is half du. Now, any constants that we have in our integrand, we can pull those out in front of the integral symbol, okay? So, of the integral. So, half and du, got it, that's our x dx. And then now what's left is this e raised to the u. So e raised to the thing that we called u. And this, the whole point of the u-subs is hopefully it's a lot easier integral to integrate. This is, right? The integral of e to the u is just e to the u. Okay, so this becomes half e to the u. Now once we're done integrating, don't forget that constant of integration, that possible constant. Again, integrals are anti-derivatives, right? So when I take derivative of a constant, it disappears. When I take the derivative of it, it becomes 0. So when we integrate, we have to consider there may be a constant of integration that's sitting there. So we get half e to the u plus c, and now we do what's called back substitution. In other words, now the original problem asked me for x stuff, not u stuff, right? And so we plug that x stuff back in. In other words, we know u is x squared. And so this becomes half e to the x squared plus c. Okay. Now, when we're doing this, now the best thing about integrals is that we can always check it by, well, just taking the derivative, right? So if I wanted to check this, right, we'd say, okay, here's our check step. We'd check by just taking the derivative. So we know half, okay, e to the x squared plus c. Now I'm taking the derivative with respect to x, so d dx of this expression. Well, the derivative of half e to the x squared, again, that constant comes down if it's attached to some x stuff, right? So this becomes half, and then the derivative of e to the something is e to the something, but then times the derivative of what we call the inside. It's by our chain rule, right? So really a u-sub is undoing the chain rule, right? So the derivative of the inside, our inside here, is this x squared. So take the derivative of that thing. So the derivative of x squared is 2x. And then the derivative of a constant, of course, is just 0. And so simplifying this, we get, well, the half and 2 would cancel. So we get x e to the x squared, which again is our original integrand. All right, so if you're keeping up with us for the 40 days, for the 40 solutions, right, make sure you save this video and then hop over to my YouTube channel so that you can get all the solutions to all the videos, okay? Always remember, math is everywhere.